Greetings. This is a report presentation on Make My Trip classification problem, and we are doing the applying machine learning classification algorithm on the data set and getting inferences from the data. First of all, I'd like to mention here that first of all, the data set that we have taken, it is an anonymous data in which the name of the input feature is not given. They are random input features. So we just know that there is a target variable that we have to predict that is referred as p, and this is a class. Okay. So there are 17 columns labeled as A to P, out of which A to O columns are the features, and P is a label. So as you can see, the data set can be can be downloaded on this link, and it will contain these three files. So moving uh, to the questions part that we are trying to uh, explore here, is the target variable skewed, or the outliers will be present, or the null values in the test and train data set, and how the data is distributed column wise. I will do the univariate analysis for the same. So regarding the data description, it has 552 rows and 17 columns, and for the test data it has 138 rows and 16 columns. So there is a reduction of one here, because obviously we need to predict the p, that is the target variable in the test data set. So we have to find out using our model. Okay, so data quality, as we have said, that it is good, and missing values, we'll find out missing values, the duplicate data, the outlier part, the skewness part, one by one in the data pre-processing steps followed. So I'll start with the data pre-processing step, and first of all, what I've done here is that I've imported the libraries linear for the linear algebra and NumPy, and the matplot library for the for plotting different graphs. Here I have read the imported the data files. So when I have drawn this uh, dot head function, then as we can see that data set is not that big, so we'll have a look at more of the rows. So when moving to the analyzing target variable, we can see here easily that it is either 0 or 1. Here one can conclude that this is a classification problem, because the p is the target variable that we are going to find out using the machine learning model generated. Okay, so what we'll do now is that we'll check for the null values in the data, and null values and the skewness of the data we'll try to check, and if found the null values, and we'll try to replace or fill those null values, the best suitable method that we can apply there. Okay, so dot describe function here is listing out the measures of central tendency, as you can see here. So now what we'll do, that since we know that there are 16 input features, and we have so we'll do the univariate analysis, and univariate analysis is the analysis of the columns one by one respectively, and getting inferences from the data thereby. So we'll start out with the column A analysis. As we can see that we first try to find out the percentage of null values in the different columns amongst 16 features one by one, followed by and because we are doing univariate analysis, and um, if found a significant difference, then we try to replace those null values uh, with either the mean, median, or mode data. And so here, yeah, here in the column A, the training set, it is 1.45 and it is 2.90, which is approximately double. So we'll try to replace the null values with the mode, that is uh, the maximum, since with the b variable, because it is occurring more number of times. Yeah. So in the same manner, moving to column B analysis. Uh, the column B analysis, here we can clearly see that it is an outlier, and this column B is comprising of continuous data. So, and it does contain the null values. So we'll also replace, we'll also fill those null values. Okay. So what we'll do here, that I forgot to mention prior, is that in order to remove this outlier, we cannot use mean approach, because as we know that mean is greatly affected by the presence of the outlier. So median is the best approach in the to fill to remove median is the best approach to fill out those what we say null values in the data, and uh, that's why we'll be applying the uh, median here. We cannot apply the mean approach. Okay. Uh, Now what we try to do, in order to remove the outlier, we try to bring it close to 99 percentile, whichever crossing 99 plus percentile ranges, and below 1 percentile ranges the data point that they are crossing, we try to bring close to the 1 percentile ranges. Okay, so in the same manner, we'll be doing the different analysis for different input features or the columns. This is for the column C analysis. This is the scatter plot that we have that we got, and we can see that we did got the outliers, and we tried to merge those outliers into the 99 percentile ranges. Okay, in the same manner, I've done the column D analysis. Uh, as we can see that here, this is uh, a data in which we need to fill these y uh, y number of occurrences for the variable y with the u, uh, or in other words we can say that with the mode value of u, in the similar manner for column E analysis. uh, Here, one interesting point that is to be noted here is that since it is containing three variables, namely named as G, P, and GG, and whereas in the test data set it is containing as G and P, so we need to remove this GG variable from the training set data, uh, and we'll do the same in the further analysis of the columns, or what we say the univariate analysis of the columns. So this is the column F analysis in which we have generated the pie chart, and for the blue part this is 21.1%. This was the null value uh, that I found, and I replaced it with a mode value that can be seen clearly here. uh, in the same way, column G analysis is done. It is generating the histogram, and different DD variable is shown here. J variable shown, and is shown, Z is shown, but O variable is present only in the training set data here, and that is not present in the test set data. To then we have to delete those set of points. Okay, so moving forward, the column H analysis, that is we are getting this outlier here. Okay, so we will try to remove the outlier and bring it to the 99 percentile range. And this column I analysis is following the same here. We don't need to fill the we don't need to what we say, this seems to be a perfect data as, so we don't need to bother about it much. In the same way for the different column analysis up to okay, so for this column K analysis, this is again we are getting here is the outlier, we will need to remove it. For the column A L analysis, okay, this seems to be a perfect data, no null values are present. And for the column M analysis, no null values are present here also. Mm, for column N, there again it appears to be an outlier here, again for same for the problem. So uh, all in all, for the common part, uh, we are getting null values, a few null values and a few outliers, so we would have to replace those outlier values and fill up those null values that I have mentioned in the starting part of the starting part of the report presentation. So moving ahead for the column O analysis, again we are getting at the outliers, we would need to remove those outliers with a 99 percentile. Okay, so here what I have mentioned here is that for the different column following univariate analysis, uh, I have drawn some inferences which I have mentioned that I'll be narrating. Column P, as we can see, as we have seen, not skewed data set, but it is a binary classification base. That this is the inference that we have derived from here. In column A, 1.45% of training data values are null, and in 2.90 of test set data. So we would need to fill those values with variables whose frequency is more. That is the mod value. And for column B, we will remove the null values within variable whose frequency is more. For column C, no null values few are present, only few outliers are present here. This is, and there has to be a comma. Okay. uh, for column D, there are a few values which are present in training data but not in test, so need to remove those values from training data. For the column E, again is same as column D. Few of the categorical values are present in training data but not in test data, so we needed to delete them also, as we have done prior. And for column F and G, many categorical variables values were uh, inferenced. For column H, only need to remove outliers I, null values, and perfect data, no null values for perfect data. For J2, for column K, we needed to remove the outliers and proceeded in the same fashion. For column L and M, perfect data was observed. For column N, remove outliers and fill the null values. Column O, many outliers are present, and remove them and look the result. Okay. Here there's an important part that we will be getting, that is we'll be generating the label encoding, and in one hot encoding. Why label encoding? Label encoding is basically used because if you are having a input feature that is in terms of word or characters, that the machine learning model doesn't recognize it, we have to give it a number, a mathematical value. So in order to do the same, we encode it by using a label encoder and one hot encoder. Okay, now I'll uh, move to the machine learning algorithm application part, and I have taken three algorithm, that is logistic regression, KNN aggregation, and SVM regression. And okay, so we have taken these three different algorithms and we have calculated the accuracy. So it was 82% for the logistic regression. For KNN it was 78.9%. For the SVM it was 80.4% that was coming out. Okay, so basically I'll explain these three classification algorithm, and so I'll start with the logistic regression. Logistic regression is a predictive analysis and which is used to describe data and to explain the relationship between one dependent binary variable and one or more nominal what say ordinal, interval, or ratio level independent variables. Okay, so just we need to ensure here that no outliers are present while using this algorithm, the logistic regression part. So we have removed the outlier, and here we have calculated the confusion matrix, we have calculated accuracy, precision recall. Okay, moving ahead to the KNN algorithm. uh, KNN algorithm. Following the KNN algorithm, it is basically the one of the simplest classification algorithm, and it is also a non-parametric lazy learning algorithm. It being lazy means that it doesn't use the training data points to do any generalization, or in other words, there's no explicit training phase. It's very minimal. So uh, its purpose is to use a database in which the data points are separated into several classes to predict the classification of a new sample point. And using the SVM classification algorithm, we were getting the accuracy of 80.4% in a similar manner. Uh, Now, lastly, I've used this sorry, uh, for KNN, I was getting the accuracy for 78.9%, and for SVM, I'll get the accuracy of 80.4%. So, SVM, it is used for the it is a supervised machine learning algorithm which can be used for both classification and regression challenges. How it is mostly used in classification problems here, but in this algorithm we plot each data item as a point in n-dimensional space, or what we say n, the number of features that we are having, with the value of each feature um, being the value of a particular coordinate. Then we perform classification of finding the hyperplane that differentiate the two classes very well, and in this way we apply this machine learning algorithm.